Hello, custom filters. If you'd like to learn about how to add a custom filter component to AGGrid, you've come to the right video. As you can see on the screen, we have a very basic AGGrid with some dummy data, including 3 columns, make, model, and ponies. They should allow us to play around with some data. What we're trying to replicate and then extend is this filter component, which, as you can see, has basically an HTML select, an HTML input, and is able to perform a number of filtering actions, including contains. So filter by anything that contains the word O or golf. It should be none over here, I guess. Volkswagen. And then you can do equals. So this doesn't equal anything, but this does. Or ends with Aru. Subaru ends with Aru. So that's the functionality we're going to at least reach, and then we're going to extend it with, in my case, I needed a list filter. So I needed to be able to match against, let's say, Volkswagen, Ford, and Tesla, or not contained in Audi, Subaru, or Ford, or whatever. And I was only able to add 1 string at a time with this list, or to be honest, they can do 2 as well. But I needed to do many. So I'll show you my list filter as well at the end. So here you can see our basic grid. In order to create a filter, we actually need to make it a component, of course. So let us generate one. I'm going to generate it in our AGGrid parent folder, ngg generate component. Custom filter. Okay. And here we are. And we are going to need to register this custom filter in the grid. So it's already in our app module, probably right here. So we just need to add it to our grid. In order to show you the contrast of the default and my personal filter, or our personal filter, I'm going to show you it on just the leftmost one. So filter framework, custom filter, component. So now make should use this filter, which of course at this point is just going to show custom filter works, and it's probably going to be pretty glitchy. So I'll show you that. Oh, there, custom filter works. So now let's go actually implement that filter. AGGrid wants us to implement their interface to get this started. So let's show you that. It's IFilterAngularComponent. So now it's going to be annoyed at us because we haven't actually implemented it yet. So here we go. We're not going to use ng on init. We're not going to use a constructor. Let's get rid of those. And then, yeah, as we see, we have this little AG lifecycle method, AGInit, which I'll put at the beginning, is filter active, does filter pass get model and set model, which I will explain soon. But first, I'm going to show you we're basically going to use an enum to store the types of filters that we're going to work with. That's one of the first things. So we want to, it's a pretty obvious data type for this. So we are going to just write out every single one that you would expect to see on the default filter type. I'll speed through this in the video just so you don't have to watch it all. Okay, so now we have an enum containing the filter types that we are expecting to implement. So just to refresh your memory, what we're looking at is, go to the default one. This is going to be the filter type. Contains, not contains, equals, not equal, starts with, ends with, and mine will be is contained in and is not contained in. This is a list of strings which we will, the user will be presented the strings that the enum equals, and the enum itself will be used for code completion. The filter is a text input. So we are going to want to iterate over these strings. So we will want to convert the enum into a database that we can use in the code. So let's just do that. Okay, types, string array. This is a cool JavaScript thing just because it's not a real enum. It's just an object. We can break out the values of filter type to get contains, not contains, this side of the equation. To take another look at this filter, what we're going to actually want to create is this entire thing in HTML and CSS. As we can see, we have a div, which we will call the filter container. We have these two inputs, which should have similar styling. And this will be a HTML select, and this will be an input. So I'm going to go put that down in HTML, and then if I'm honest, I'm going to copy and paste the CSS. So you'll see that momentarily. Let's get rid of that starter text. And here we have the first div. This is going to be the filter container. And then I'm going to add a class that will be common to both inputs called the input container. It'll have some default styling. I believe I use it for positioning. I'm adding a few things in here that'll be explained shortly. This is the form control, which we're going to use to keep track of value changes. And then we're going to actually iterate right here over all of those filter type enums that we talked about earlier. So now each of these options will display the value of the filter. So for instance, is contained in, or starts with, or ends with, the ones with the space in them. And they will also have the value of that same filter. So the same displayed and logical value. Here is the text input. And this is that filter text that you see right here, filter ... And then it's got a class of input. And it's a self-closing tag. We're going to use this little hash, octothorpe, whatever you want to call it, to refer to this input as a view child. Okay, I'm just going to copy and paste in the CSS that I'd written before. And I do recognize that I use margin 0 auto. And some people may want to use Flexbox. It's also not perfectly replicating the original, so most users wouldn't notice it, I think, but if you're a stickler, it's worth looking into. Okay. Now that we've got the HTML added, we've got the multi-select or rather the select input and the text input, we're going to add a couple of controls to actually manipulate those and listen to the changes in those inputs. So first, let me add reactive forms to the app module right here. So here we have a form control with a starting value of filter type dot contains, which is, as you can see, uppercase contains. This is going to correspond to the select one, and then this one is the text filter, which is going to start with an empty string. Having a hard time typing correctly because my microphone is in front of my face. Okay. Now we've got a form control that corresponds with the select box. We've got a form control that corresponds with the text input, and we need to implement this AgInit method. We are nicely provided filter params, which we can use to get things started. What we're going to want to do is first listen to that text input and listen to value changes. So this is going to fire whenever the value is changed. So here we are now listening to text input changes from the user, and we are responding to it in some way. Of course, we haven't implemented onChange yet, but we will shortly. Once we do, this will make a little bit more sense. Now that we're listening to value changes in both user inputs, we're also going to set the value onto the filter type input just to get things started. Set value this dot filter types 0. Now that we're listening to user changes to the inputs, we're also going to use AgInit to provide us with a helper function that we'll use later. In this case, does filter pass provides us these params, but we need to get the column ID that we're using. So the column field or the identifier for the column that we're in this case make. We need to get that from here and provide that to a helper function so we can access the value later in does filter pass. I'll show you how to do that now. Okay, as you can see, we took the value of the column def field or the ID from this params object, and then we passed it into this callback, which we're storing up here, which takes in these IDoesFilterPass params and uses it to access the row column value, so that cell value. Okay, we're almost done with AgInit now. We just need to do one more thing, which is to manage these subscriptions. These subscriptions will persist after we are done with this custom filter component because they have never closed. So one thing we can do to that, to manage our subscriptions and to prevent a memory leak, which I have run into before, is to use this semi-new feature, which allows us to cleanly manage unsubscribing from a lot of observables at the end of a component's lifecycle. So here we have this subs object, and we're going to add these subscriptions to them, to that. .sync. So we just add them to the subsync to be managed with this simple syntax. And then we need to actually delete them on destroy, which the subs will handle for us. On destroy this .subs unsubscribe. Okay, so now we have these two subscriptions, which will be destroyed right here once we close out this component. Okay, we're finally about to get to the meaty stuff, which is these 4 methods right here, which were forced upon us by implementing the interface IFilterAngularComp. What do they mean? And sneak preview, by the way, I did have to go and add this method because it wasn't compiling without it. But regardless, these 4 methods. So the first one is filter active. That is simply the grid asking us whether it needs to bother with this filter, whether it needs to look at it at all and apply it to filter out certain rows. So if we return yes, the filter is active, it will use this filter to look at every row and remove them if they are filtered out. Otherwise, it will just skip this filter. And the way we're going to do that is basically to say, if there's text in this filter, look at it, otherwise don't. There's also does filter pass. So this is just saying, given the values that we have for this row, does it pass the filter you've provided? So if the filter contains Audi and the provided row does not contain Audi, then it will not pass. Get model and set model are used for elsewhere in the application. So this is not actually going to interact with this component specifically. We wouldn't call these methods necessarily. You'll see we kind of do. But this is for if I'm somewhere else in the grid and I want to, in a callback, grab this model, check out its state, and then maybe set the model depending on that. We need to implement these so other parts of our application can interact with this filter from outside. So get model is going to return the state of this filter, and set model is going to modify it on the fly. Whereas from here, we will use other methods to set and get the filter. So first, in order to get and set the model, we're going to need a model. So let us define that interface right here. Of course, you may want to put this in a custom filter model.model.ts or custom filter.models.ts or whatever, but I'm just doing it in this one page. We're going to have the type, which is a string, and the filter, which is a string. So for example, this might be ends with hi. Who knows? Now let's go ahead and implement the very easiest of them, which is, right before then, I should actually add the custom filter model. So we are going to have custom filter model equals type filter. And there. So now we have our very own custom filter state, which starts with not very much. Okay, now that we've got a current model to keep track of, we can go ahead and implement some of these functions. The first and the very easiest, of course, is going to be get model, which is just going to return this current model. And so later on, if we want to access the state of this filter, we can externally from somewhere else in the application grab it, and it'll return the current model, which might have type Subaru, type it contains and filter Subaru. And so then the next easiest is filter active. So here, I'm going to return the Boolean value of the current model filter. So it's not active if there's nothing in the filter, and it is active if we're filtering by some sort of string. Okay. Then the next crucial one, not the next simplest, but probably the most complex and the most crucial one right here, is going to be set model. Okay. So the model can be anything, but let's see. So this is where we're external to the app. We're somewhere else in the application, and we would like to set the model, basically set the filter type, or we would like to set the filter string, or we would like to set both. So one, just quick null check right here. If the model is false, if there's nothing there, then just go ahead and return. Otherwise, set the current model to be the model. There may be an edge case where this wouldn't have the type or the string, but I'm controlling this, so I know it's always going to be truthy. You may want to add some additional edge case checks there if you don't exactly trust other people in the code base. This current model equals model, and then here is going to be the meat. Check value passes filter. So this is going to say, like, given this row content, make sure it passes the filter. Get value tester. Tester model dot type dot filter. Okay, so check val passes filter. Is going to take in a string, the value, and return a Boolean. Did it or did it not pass? TypeScript is very finicky and says that, hey, if it's not instantiated at the beginning, it may be undefined. It may not be this value. So I'm having to say or undefined because we haven't defined it in the constructor. So check value passes in. The filter is the callback we're going to try to instantiate. It's going to have to take in a string and return a Boolean, whether it passed. So we obviously need another method called getValueTester. Which takes in a filter type and a filter. To make it so that the case doesn't matter, we're going to first lowercase this. So to keep the casing out of the equation, we are going to set the filter to be lowercase. So that is the filter of the model, or rather the filter of this custom filter. So it might be, in this case, Ford or something. We don't want to care about that uppercase F on Ford. So just keep it lowercase. Usually users don't care about that. Obviously, if you wanted to, you could implement that otherwise. And then we're going to switch on the filter type and perform a bunch of different possible actions. I'm going to rip through this and maybe explain them one by one. Okay, now we've finished setting up all the standard filters. And by the way, these were nicely provided by AGGrid, although it took some time to understand what was happening here. But yeah, so this callback, of course, is given to the filter to find out whether, or actually, we're going to use this callback to find out whether the filter passes. And in this case, if it finds this string in the larger row value string, then it passes. If it doesn't contain, if it's exactly equal or not equal, or if the index of this matches with the starting index of the row value, or this one, of course, being the most complicated, finding out whether it ends with the filter type or the filter. But now we have a function called this check value passes filter, which we've stored in the custom filter component for use later. And one other thing, we're going to want to set our reactive form controls values to match with this model. Because this could have been done from externally in the application somewhere else, and these text inputs, the user is going to expect them to reflect the value that has been set by the program elsewhere. So let's do that now. One thing that may not immediately be obvious, but if we set this model and from externally in the application, and it triggers a filtering check, and then we set the values of these inputs, which is going to trigger this onChange function, which later on is going to trigger this same function, we could enter a loop. So what we need to do is set the value so that the user sees the value has been changed, but we need to not emit an event, so we do not trigger an onChange cycle event. Okay, so now we've got set model. We're given a model, we check to make sure it's valid, we set it to be the current value, we set up a new check value passes filter using a switch case to establish which callback to use, and then we set the values to the two user visible inputs. Moving on to the final interface method, does filter pass. So right here this is when the filtration has been set. We know we need to filter by this value, or we need to use this custom filter, and the AG grid is iterating over each row, giving us the row's data and checking against the model that we've set up. So first we get the value of the column, which we're going to use the value accessor we set up in AG init. So we're going to assume that's there, get a little existential operator, and then pass in the params. I does filter pass params. And so now we've got the value of that row, that column, so that cell value. Return this dot check value passes filter. Again, existential. Not sure if I need this. Okay. We know that value accessor and check value passes filter are going to be legitimate callbacks by the time it reaches this, but TypeScript is unsure and very shaky about it. So let's assure them that this will return a string and check value passes filter will return a Boolean, and move ahead. So this is just going to go row by row, checking to see if it returns true, filter it, or pass it, or false. It doesn't pass the filter, and to remove that row. Now, finally, we are going to need to implement that onChange function from earlier. So it's actually going to be a partial of the custom filter model. And we're going to set the model. So let me show you how this wires up. Up here, we're listening to changes of the filter and the filter type. If there is a change, it triggers this onChange with an object containing, in this case, the key of filter and the value of the new filter, or in this case, the key of type and the value of the new filter type. So this might be type, object containing type type contains, and this might be an object containing the key filter and the value Subaru. So that will trigger this function on change, which I'm going to reuse set model. So we assign the new partial of this overall model. So maybe this will be the object with type and of contains to the current model. So that will retain whatever was already in the filter, or whatever was the opposite of the one we're setting. And so then that's going to call set model, which is going to have a valid model. It'll set it, and it'll establish a new callback, and it'll set the value to both the filters. This will be redundant in this case, but if we were setting it externally, it would not be. There you go. Okay, we're getting extremely close to wrapping up, at least the re-implementing the default filters. But I did neglect to mention one thing. We do want to save the params provided by AG init, so we can call a filter callback. So here, here we now have the params provided at the initialization of this custom filter component. And on change, we're going to want to call this params dot filter changed callback to let the filter know that it may need to check again. And with that, we should have re-implemented the provided functionality. Sorry. And a breakpoint. Probably hit another one too in just a little bit, so might as well head that off at the pass. Good. That's a good sign. Subaru. Okay, nothing like that exists in there. Check another one. Starts with sub, or nothing really starts with UDI, so that's good. Nothing starts with ORD. Something does end with it, or D. Cool. Okay, so that's looking pretty good. We have our filter, we can click into it. One thing you will notice though is that when we click into this filter, the provided one, the focus is immediately drawn to this user input. We want to replicate that here. But unfortunately, at the moment, we have to click into it. The way that we achieve this is pretty simple, though. So let's go to the top. And we'll actually need to access the input. And that is where this little hash comes in useful. So let us grab that input right here. Okay, so the reason we need this is because we're going to need to access the native HTML element to provide it focus. So here we're accessing the view container ref as input, and after GUI attached, we are going to be given some params, which aren't going to really matter, but we'll take them in case we need them for something else in the future. By we, I mean you. And then window.set timeout. So the native element focus. So this is just saying get the native element of that user input. Should have just said any. So we are going to grab the native element of this input, and the window is going to focus on it after asynchronously, right after it's loaded. So now it should replicate that auto-focusing functionality, which it does. Great. So I can filter immediately. That is definitely a nice little convenience feature. So finally here, I'm going to add the custom filters that I made. Should you find them useful, if you need to filter against lists of data, the first case is filter type that is contained in. Okay. This is obviously a method that we haven't implemented yet. Let me go implement that. So the way that this filter is going to work is it's going to be a comma or space or comma and space separated list of values. So perhaps Audi, comma, Subaru, space, Volkswagen. And this filter is going to check to see whether any of those values are in the comparator, the one that's actually in the cell. So first, let us split that list of strings that the user or has typed in or we have set declaratively. Okay. Split on this regex, which says one or more strings or commas. That is incorrect, of course. Okay, so now we've got a list of the strings we're checking for. Okay, now the value presence tester is going to check to see if the value that we have in that cell is within the list of filtering strings. And in order to make that a O-of-N operation, speed it up, I first convert this list into a sort of Boolean checker. You'll see I put this in a general.utils class. Here we have array reduce. Basically, we're building a hash map out of the array, where the hash map is the filter strings with a Boolean of true if it's present. And then the callback is going to take in the cell value, which is a string, and check the Boolean value of here. I did do a double equals here. I have run into issues with this. I would recommend re-implementing it precisely. I at first assumed I didn't need to get the Boolean value. I could just get the truthy value, but that actually didn't work. So this is the result of some trial and error. I would actually recommend doing this precisely rather than trying to do triple equals or not include this. Okay, so now we've got get list filter. Basically, it takes in the user filtering string, the list of values, converts it to a Boolean presence tester, and then inserts that into a callback that we can compare against the cell value. That is contained in. And of course, is not contained in is going to be a fairly easy opposite. So check if it's equal to true or check if it's equal to false. All right, now we've got our list filters instantiated. Previously, if we had not implemented this, it would have hit the default, warned the console, and broken, and not filtered. So that's what we're looking at now. Hopefully it has compiled, and we can check against a list. So let's see, try some shorter ones. Audi. It's not working. Oh, sorry, of course. Is contained in Audi, Ford, space Volkswagen. There we go. Is contained in, is not contained in Subaru, Tesla, and Smart. There we are. Yeah, so obviously if you need to use semicolons, you might want to replace commas with semicolons, whatever you want to do. Okay, now we've reached code completion, but I'd like to take a step back and summarize what we've done. So the first thing to do was to replicate the HTML you see here using a selection box and a text input wrapped in a div. As you see, a selection box and a text input wrapped in a div. Then we wired those actual inputs up with Angular reactive forms here, filter type and filter. We then defined an enum called filter type, which would define all of the options users could choose among within the filter type selection box. We next prepared our component by implementing the AG-Grid IFilterAngularComp interface, which sketches out a bunch of filters that we then have to implement more completely in order to have a valid IFilterAngularComp component. Next, we implemented the AG-init method, where first we store the params for use later. We then listen to value changes on the user inputs filter and filter type, which we handle the responses with on an onChange method. And then we defined a value accessor, which we could use later to grab, given an IDoesFilterPassParams object, we were able to grab the specific cell value from this column on the AG-Grid. Next, we proceeded to define and instantiate a model, including a type and filter, the type of which can only be chosen from among the options in this enum. With our newly defined current model, we implemented the very simple getModel method, which just returns the current model that we maintain throughout this component, which allows programmers who want to check on the state of this filter a little peek in at what's happening with this filter, which they can then use to make decisions. For instance, whether they'd like to set the model, whether it's in a good state already, etc., etc. We then implemented isFilterActive, which is quite a simple method as well. It just checks to see whether the user has input any text into the text input field. And if they have, then it will go row by row with this filter, checking to see if each row passes. And if it hasn't, then it'll skip it altogether and just presume that all rows pass, which of course they do. Next, we implemented the meatiest function of them all, setModel, which is potentially set from when the user inputs values here and onChange, which calls setModel, or also from elsewhere in the application. If a programmer wants to set it programmatically, they can do so. We store the current model as that which was entered. We then store a callback, which will be later used in doesFilterPass, called checkValuePassesFilter. And for that, we use the filter type, the switch case, and the string comparator value that is defined as the filter, which is this, which then defines a callback, which will be used to compare each row. And then, of course, if it has been set programmatically from external points in the application, we have to set the filter type and filter HTML inputs with the value as well. Although, of course, if the user set it, we don't need to do this step, but we do it for all of them just for consistency. As referred to earlier, does filter pass simply accesses the cell value of the this current column and row, so the cell, and then checks to see if that particular value passes. If so, then the row passes. Having reached this point where we were nearing the end, but we did have a convenience feature here after GUI attached, which automatically focuses on the user text input field, so they can start typing immediately once they open the filter, which is sort of the expected UX flow. And then we manage our subscriptions using subsync, just right here. And we then destroy them in ng on destroy. And with that, we have a completed custom filter. So go ahead, extend that, take it to new heights, and I hope your application comes out great. Have a great day.